All right, great. So about half of you are new to the industry, so I think this is a good overview of just the unit steps that actually happen in the plant. It'll give you some basis in process design, so if you're in that planning meeting about upgrading a process line, you'll have some good basis in that. This next video coming up here is shared with Trulieve Farms. They're a great customer of ours. This really highlights what happens in a fresh cut produce plant and where the kind of the roots came from in the industry. So there's a number of companies that each fall and spring, they literally tear the complete facility down, move 20, 30, 40 combination scales to the operation in Yuma. And this kind of shows just the sequence of events which has driven how equipment is designed in a lot of cases. So it's kind of a neat video. There's some audio that's not in the overhead, but that's okay. So right now this plant is in San Juan Bautista and it's moving to Yuma, Arizona.
This is not uncommon.
Yeah, this is not uncommon.
This is one example, but there are multiple plants that take this migration.
So it's quite the, I mean, just the months of preparation prior to pulling this off is pretty amazing. And then to be back up and running within 3 days. 64 hours start to finish, 55 truckloads of equipment.
Can you verify that last picture?
And this is probably, I think this is about 5 years old, this video sequence. And each year they've been able to shave off hours off of the dismantle the runtime, which is pretty amazing. So going into the equipment presentation, just a real quick review. Spread the knowledge on design zones through everybody that is in that design team. So maintenance workers, sanitation workers, everybody purchasing. You know, somebody buying equipment, that they should know about these hygienic zones, and if they're getting competing quotes, they should be versed to make sure that is that vendor even qualified to be quoting on this project. So I won't spend a lot of time on that other than a little bit on zone 2. You can see in the picture here, there's a lot happening here. So this zone is after the wash. What would we call this? High hygienic? Okay, good. So here's the extent of the theoretical math we use in process design. A lot of it's based around dimensional analysis, just evaluating production capacities. All the unit operations I'm going to talk about, a lot of it is, as you go and improve your processes, it's bottleneck identification. Where's my current bottleneck? So understanding how to go from 45 bags per minute at 1 pound bags based on 50-minute hour, or are you based on a 60-minute hour? So those are average capacities versus peak capacities. That if you base on a 50-minute hour, you'll typically stay out of trouble when you actually want to look at your end of implementation capacity. Also, the process plan, I'll talk a little about batch processing versus automatic processing. Automatic processing in the produce industry is just, it's still batch processing. Every step is still a batch. You're just handling it mechanically in a different fashion. So these are your unit operations. You'll have a quiz at the end of this, so you will all be experts in every one of these steps, right? So how do we start? Oftentimes you have what we call current state. Current state's really good if you can create some type of process chart. Does not need to be a engineer-driven document. It can be just squares, writing, all right, we're receiving product. What do we do in the product next? With new engineers we work with, oftentimes we have a guided discovery process. We say, all right, become that head of iceberg. All right, you're in a truck from the field. You go through vacuum cooler. You now get delivered to a plant. You're staged in a flow-through rack. from the rack where you get bin dumped. You're now in a cube, 4x4x4. Now you want to get it down a single layer, so now you're a single layer conveyor. What's next? You're going to go through a propeller called the TRS, get shredded. Your next is going to become washed. So part of you just lost as a defect, maybe lost a foot or an arm. So that's how we like to train employees. Become the product. We want you now to verbally go through, as you go through from bin to bag, explain what's happening to me. Once people start to work that exercise and look at the world that way, they can start understanding each step and how to improve it. So as we go through these, if anybody has any questions, please raise your hand. There are some videos here, see if I can get them to run. See if I can turn the volume down now. So that was a bin put in sideways on a bin dumper. You're going to notice a large amount of debris is going to be dropping out right about now out of the bottom of the bin. So that's very common in bin dumping. A technique called a dual cradle bin dumper, which you see here, it actually leaves the base pallet behind and it rotates the cardboard over, which eliminates in some cases down to maybe what was per week reports of wood debris in your finished package of 10 to 20 per week down to 1 or none in a lot of cases where companies have adopted this approach. A lot happens in the bin dumping area. There's forklifts, there's hand trucks. This is a typical scene, very chaotic. You also have workers in this area, hand dumping. There's also different types of containers from bulk bags, which you also have to figure out how to dump safely and cleanly. Cardboard debris, liners in every bin present a lot of challenges just in debris management. So what we learn about zone walls in the facility part is segregation. So having a separation wall between raw product and your next step, which is the ready to eat zone. Very typical, a lot of romaine is hand dumped case-wise. Does anybody see anything odd in this picture? We talked about openings, right? We've talked about temperature differentials. Your raw product cooling storage area may be running a little colder. You may have roll-up doors going up and down all the time. It could be 2 to 3 degrees colder in that area versus what's the opposite side of the wall, the ready-to-eat zone. So you see an opening, right? And then you wonder, what is that stainless piece here for? So could be, my guess, anybody have a guess? Yep, condensation. All right, so here's a company that actually has recognized that anything in a zone 2 surface can drip, drain, or be drawn onto a finished product. So here's the workaround solution to deal with condensation, which is going to occur in those areas. You have a wall that goes up 30 feet, condensate on, it's a matter of time, a little vibration, all of a sudden that stream starts to get energy and will cascade down off the wall. So that's a great solution. So here's another example of bin dumping as lines now are approaching 20,000 pounds an hour, between 18 and 20,000 pounds an hour. On a food service line, you're looking at dumping 2 full bins every minute and a half. And those bins all have liners, they have broken pallets, etc. So a very chaotic environment. Example of floor loading, so a lot of smaller regional companies will work with a pallet jack in these areas, and there's still some areas you can see here, this operation went in without any zoning, hygienic zoning between the bin dumping area and the process steps. Here's another example just of as we put walls up between process steps, there becomes a communication issue, right? So if we are having one person loading with everything else, factoring in lockouts for equipment with floor sensors for floor safeties, you may have separate workers bin dumping. There are automatic versions of these where the person on the opposite side of the wall may be actually running the bin dumper with a camera system going through. So a lot of challenges operationally to keep a safe environment. And just here's a picture. If you haven't seen a bin with plastic in it, this was an automated system that would dump 2 of these bins. This line was averaging about 1 minute, 20 seconds between bin dumps. So part of the prep getting that bin so it could actually dump safely with a plastic liner was the biggest challenge, and it led to some redesign of that plastic liner, how it folds together, and just how to prep it before bin dumping. Also, very common blending products that continues to be a challenge in fresh cut operations. Where do you blend? So some smaller regional companies may be doing locally grown spinach spring mixes. They may be buying from Truly, for instance, in which the blending operation is taken care of ahead of time. But this is a common practice, bin dumping and blending in the finished product area, washing products. There's also post-blending. If you're doing an iceberg blend of lettuce, cabbage, and carrots, those all have different sequences of operation, so that's a whole nother level of blending to occur in a high hygienic environment. So we talked a little bit about becoming the head of lettuce metering. There's a lot of great techniques now for metering that didn't really exist or weren't apparent. Kind of the cascade approach, where you can take a large volume in one hopper with photo eyes and slowly get it leveled down to a single layer, is important, and it can really help with the overall functionality of the line. Factoring in hand dump areas, although all these designs are designed for bins, there's always that portion of the year where you can't get a full bin of product. You have to deal with case product on a temporary fill-in basis. Also point out on this end the installation of the electrical panel in the conduit. There are some geographic areas where you are forced to use rigid conduit for your electrical. This is an example of a project we did in the Pennsylvania area, which the trade unions are extremely strong, and normally we'd like to see cabling, but you see a lot of this conduit creates a great harborage point for bacteria, listeria. Oftentimes you can see on the side of the equipment there's conduit, becomes a stepping ladder for workers to clamp up on equipment, and then you're allowed to go to conduit or flex towards the end of it, but it just always amazes me sometimes how sometimes the Uniform Building Code hasn't caught up with sanitary design. So the next step is mechanical inspection trimming. You see a trim line in the upper hand corner. Very common for a lot of companies now. These are basically just transport conveyors. A lot of the trimming has migrated into the field, but there's always that point in time where there could be a 1 week, 2 week period where you have to core in the plant. So a lot of companies still dedicate space to allow that. There's also debris that comes off, a lot of waste in this area. This is also the ready to eat zone. So this is where you're prepping the product. You're doing the microbial reduction of the load, stripping off defects, inspection, hand sorting. There's also a pretty good waste stream coming out. Earlier I talked about the pneumatic conveyance systems. Here's another picture of a conveyor collecting multiple lines and then conveying to one pickup point out of the plant. It's also very common for smaller operators to do some pre-wash in a tote. So if you're getting locally grown bell peppers, and you're going to be taking those in, coring them, dicing them, slicing them. It's very common to have some type of pre-wash, a single pass sanitation step, just to surface disinfect that bell pepper prior to the next step of size reduction. So there's a whole category in this area of mechanical foreign removal, from vibrating shakers, expanding roll sizers, taper bar graters for broccoli, air cleaning. Let's see if the video starts. So this is a vibrating table. It has a grid on it, and between 1/2 inch to 7/8 grid allows small pieces. So if you're running spinach on this, it could be cotyledon leaves you're trying to remove, small pieces of dirt, small pieces, tip cuts. You want to try and remove as much of that as possible. Also, air cleaning, air separation, it's called density separation, is very common. In this case, we've got celery sticks dropping through, which is the good product. Defects are then being blown up, so all the leaf are being blown up. So simple machine like this at 3,000 to 4,000 pounds an hour could actually replace 12 to 16 people hand sorting product. So it is an automation tool that's available. There's also rotary cleaning reels, more prevalent. in the frozen food industry, but some of the kales we're seeing now, which are very hardy, very durable, this is one of the good methods to try and get, especially the curly leaf varieties, of getting dirt clods and other debris to drop out of those wrinkles that occur. So Erwin talked a little bit about foreign mechanical material removal, BEST. Optical, which is now owned by Tom Rudd. About 2002, I believe, they invented what's called fluorescent laser sensing. So they're using a red laser to look and sense what's fluorescing. So typically things that do not contain chlorophyll are identified as defects. So anything that has chlorophyll will be dropped out. So this video shows a vertical drop through, so the product is elevated up, then as it drops through, it's being scanned, and then an air jet is blowing the defects out of the airstream. Typically, this is done in the ready-to-eat zone where we're doing microbial reduction. There has been some attempts. We've moved it a few cases into high hygienic. I don't think it's as effective there in that zone. You really want to try and get your defects out in this zone where you're doing all your microbial reduction. So this is a great video. This plant's been dismantled, but they went out of business actually. But it does show you all the steps from a bin dumping step. You can take a look at the time motion study of the guys that are prepping romaine. They're getting ready for size reduction. I know in the Salinas Valley, a worker can probably do one head every 3 to 4 seconds on average in some of the hand cut operations. And you can see here that we're not really too tuned into getting production out. Anyway.
I didn't know you were filming me that day.
So we've now got the product prepped through mechanical, sorting size and everything else. Now we're going to cut it. We're going to size reduce it. Here in North America, Urschel is the predominant supplier of those cutters. We've got a lot of knowledge over the years of these machines need maintenance. If you can design your facility to get it in and out safely, having blade storage areas for tooling changeovers. There's always debates, slicers on the ground, slicers raised up, do we put cut product on a conveyor belt, do we dump it directly in a wash system? Those are all pros and cons and compromises that are really based a lot on your physical constraints of your facility. There's also specialty cutters that are used in this area. Water jets, very common for celery. Most of your celery now that has got extended shelf life will be cut with a water jet. There's also some other techniques for cutting romaine that have been implemented over the years. Just some quick installation photographs. This is a multi-product line. In this case, it's feeding a translicer, which will do a shred cut on iceberg or a chop cut on romaine. The same setup, we are feeding a Model H or G Urschel cutter. This is your typical dice cut for carrots, onions, your 1/8" dice cuts, etc. And then also we can do with the Urschel CC model is set up typically to do your matchstick cut on carrots in the industry. So this is typical for a lot of small regional operations. They may be changing this line over literally every 2 hours. So they're staging, they're running product that goes through translicer, then they go through the dice cuts, then they go to the CC cut, and they keep rotating this line back and forth based on orders coming in. This is also a photograph showing a blending operation at the cutter stage. So we've got our Urschel Diversicut, which is taking cabbage and doing your typical shred cut or dice cut cabbage. And in the background here, you see a Model CC cutter back in this area here. Both cabbage and carrots can be commingled. They're washing together. They're going through the surface disinfection stage, and then they're dried. And then now that they're dried, their stage is whipped to be blended in to iceberg, romaine, or any other blends that they need to go into. So also part of size reduction, and this is a photograph from 1993, and you can take a look at this, and there's a lot of things, if we had more time, to go through just what's changed in machinery design from then to now. But even back then, we recognized that certain products had extremely high exudate. So exudate is basically the organic matter. So when you take cabbage and you run it through a shredder, there's a significant amount of debris, organic juices, small pieces that are a byproduct of that. So pre-washing, which as we conveyed up on the conveyor belt, we have pre-wash spray bars, rinsing off as much of that exudate. We had a vibration section to remove as much as that. Then we go into the wash system, which would be chemically stabilized. So it's a huge, great technique. It's still being utilized today. A lot of companies have recognized it. How do we improve the efficiency of our wash water? And the more debris you can remove prior to that step, the more efficient your wash water will be. Here's a shot showing elevated slicers. It shows a trans-slicer feeding directly into a wash. There is a yield decision. Why would you spend more money on elevating your slicer versus putting it on a conveyor belt? Once you put cut product on a conveyor belt, although it solves the cost of the platform, you still now have to sanitize that conveyor every day. Product sticks to it. There's yield losses issues associated with product on conveyors. There's also some other cool things we've been exposed to. This is ultrasonics, cutting sandwiches, there's a lot of companies now that are produce companies, we're produce companies, now they're making sandwiches. So you go into Europe, a lot of the produce companies in the UK, they also have huge sandwich divisions where they're doing 20,000 sandwiches at 3 a.m. and they're all sold by 5:30 in the morning. It's pretty amazing. So here's a couple more videos just to show you the differences. The upper right hand corner shows you a pre-cored product. So that's where we can get the high volume. So the labor has been moved in the field for pre-coring. From here we're going over a load cell conveyor, just measuring the feed rate through a trans-slicer and through the trans-slicer through an automated drying system. Very typical of say a Taco Bell shredded iceberg product, which this line would be set up for running at 17 to 18,000 pounds an hour. And the video in the lower corner was just the same operation, just scaled down for a batch step. You learned a little bit about wash systems. A lot of great options now for companies on wash systems. There's multiple techniques, but it is, just to emphasize, it's not a true kill step. So the efficiency of your wash system is really based on the quality of your water and how you can maintain that water quality. So as we look at single pass or 2-stage, 3-stage, multiple stage wash systems, a lot of that is based around solving the filtration issue with your water. So products with high exudate could be dirt or juices. Those are going to be multi-step washes. So your first and second washes maybe just be, their sole goal is removing dirt and removing any organic debris. Your last wash is where you'd focus on chemical monitoring and injection. That's your best opportunity for microbial reduction and having some sort of reduction in that. And as we all know, the solution to pollution is, anybody hear this? Dilution. So that goes back in the wash water. We put all your clean makeup water in the last wash. So as you know, the product's wet coming out of the wash system. At 15, 20,000 pounds an hour, that could be on the average of 20 to 40 gallons a minute of water you're losing to the floor. So if you look at that loss of water just in the product alone, if you put your cleanest water in your last wash, backflow from that point on, you can maintain a lot cleaner final wash solution versus adding water at every step of the way. So those are some of the things we've learned over the years, just how to. So if you have multiple step washes, you backflow your water. So you put your cleanest water here, you're losing water with a product. You've lost what's coming out of here, put water in this tank. So the water from here, you'd backflow wash water back to make up water for the prior wash systems. So it's just a technique to deal with your water quality. Also keep in mind, investing in the best quality wash system can help you extend shelf life. We've seen as wash systems has improved, chemical injection has improved, we've been able to actually ship 1 or 2% more in moisture content with the product. So that helps on yield. So if you go back looking at the next step after this is spin drying. So spin drying in some cases was 7 to 8 minutes. The product, we were literally right at the edge of cellular removal of water. So moisture contents were down less than 2%. So, and that was really an indication of the health of your whole process, the health of the respiration rate of your bag. As the respiration rates of bags became more controlled better, we could actually ship a little more water in the product. But there's always a double-edged sword. So we've done wash systems for spinach and spring mix, and the new systems fire up, and you've instantly seen a 3% loss in yield. Anybody know where that loss came from? So the dirt and the sand that was left in your product in the prior wash system accounted for that extra yield. So and that was always kind of a shocker for some companies. On one hand, we've got a lot safer product, right? We're not shipping all this other debris. But on the other hand, the financial guys looking at your yield rates are going, oh, we just lost 3% in yield. So, and those have been measurable. Those are quantified events that have happened in the produce industry. So just techniques for washing. We talked about flume washers, tank washers, flotation washers. They all are basically adaptations of the same technology. This is an integrated wash system that kind of highlights just some of the sanitary design features of being able to open up things for cleaning. This tank uses direct injection of water for the scrubbing effect. There are some other cases where you'll see air injection. We've seen one of the downsides of air injection where it's great for submerging buoyant products, so spinaches and kales. I think that somebody took like a water lily and bred it with the spinaches and kales that are out there because they are really buoyant now versus what we saw 7 or 8 years ago. But it's a real durable product. They are hard to submerge in wash systems. So in some cases like that, air is a necessity. The downside of air injection in the wash systems, there's a potential for aerosols, right? And migration, if you have the highest microbial load on your product going into a direct air injection system and you're putting 2,500 CFM of air in that tank to agitate it, that air is going somewhere and it's carrying with it the potential to cross-contaminate. So videos tell the story. This is a spring mix. This is an open flume system. This type of system has been redesigned to really shorten up the area. A lot of the times these flumes are put in for infrastructure, just as a conveyor belt to get from where we want to have the product entering the wash system to finally where does it have to get to for the next step. You can see this is what's called an HR zone, which provides the scrubbing action for it. And then typically there's an extended area for additional residence time for surface disinfection. What we've learned now though with correct chemistry and correct contact, having a 30-second or a 1-minute dwell time is really not the measurement. It's are you hitting the product with chemically stabilized water at the right pH for a defined amount of time with the right scrubbing action. There's been a lot of studies where you do that and you're effectively getting the same level of microbial reduction over having a 40-foot long flume system with excessive dwell time. So closed flumes, there's a lot of variations. I won't go through a lot of detail in these, but they do solve a lot of engineering issues with keeping things low to the ground and then using a pump to pump the product through a pipe which contains it. It gives you great dwell time. Some of my concerns as you go through 300 lineal feet of piping is you're consuming your free chlorine in that water without having the opportunity to add free chlorine over the whole length of that line. Here's another gravity version made by a company called Tirati out of Italy. There's our version at Heinzen for doing the same type of thing. This is using the air injection and a technique called flotation washing. So these are prevalent using a perforated drum, which we go through an air injection zone. The product then goes underneath this perforated drum, Small pieces will float to the top a little bit quicker than big pieces, and they'll escape out through the perforations in that drum. And we've actually run product from the local Costco in our backyard and pulled out this kind of debris. So beetles, bugs, ladybugs, and cotyledons. So it's there. It's an organic product. So it is still alive. This is an example of kind of what we're calling our integrated wash tank system. So these are using direct injection over the whole length of the wash. They're designed to be low to the ground. One great thing about the newer wash systems with this direct injection the full length is we're pre-blending, we're balancing pH first, and then the manifold that's feeding all the nozzles, we're injecting chlorine or whatever oxidizer you're using in that zone. So over the whole length of the scrubbing zone, you have no measurable drop in free chlorine or ORP, however you're measuring the wash system. So that's different from the old days of plumbing these systems. Oftentimes we had a tank in the unit. We then had your chillers about a quarter mile away in a separate room where all the chemicals were stored. So the time from your pump to your chiller room would be about 2 minutes of transport time. Then you'd inject your chemicals, it'd go through a chiller, it's now cold, it's balanced perfectly. 2 more minutes to get back to your wash system. They typically just enter at the back of the wash system. You may go in hot at 14 parts per million. By the time you get to the end of your wash system, you're down to 10, 9 parts per million. And if there was any hiccup in that system, you think about the reaction time. So if at the inlet, if there's any hiccup that happens, the reaction time to go all the way out through that whole pump cycle is 4 to 8 minutes. Potentially, where you could be running a system that's not balanced chemically. So here's another video. It shows separation wall. Sometimes product will go through the wall to the wash areas. Sometimes there's no walls around the wash system size reduction. Just another video showing you a smaller scale flotation separation system for floating out small pieces onto a dewatering conveyor. So there's also a whole category of combination washers, washing in totes, batch washers, spray washers for roller inspection for tomatoes or bell peppers, onions, etc. There's a whole category of vibratory dewatering shakers. We've worked on some single pass wash systems that basically uses sprays through the product on a vibratory shaker, eliminating the recycled aspect of the wash system. That does show some great promises from a microbial reduction, but also you need to take a next leap in water recycling because you're using 200 to 300 gallons a minute for a single wash step. And if you've got a lot of free available water, that's great. Or you have to then go look and doing a water recovery system with advanced filtration methods to recover that water. There's also a whole category of vacuum drying that use an air shear method for sucking water off as we're blowing air on top. This video kind of shows you the basic premises. You're exciting the product, then it goes through a vacuum plenum. Really, we found the goal here is to get the water to migrate from the product to the conveyor belt. The conveyor belt kind of has a wicking, siphoning effect, and then you strip the water out of the conveyor belt to help remove it. This is often an aid for removing water prior to spinning or prior to air drying. So, talk a little bit about processed water and the solution to pollution, and how do we solve filtration inside a plant. So we have a lot of conversations that go on for hours and hours on water filtration. Can we recover the BTUs in that water if we dump it? Can we use that water for blowing down equipment in the sanitation step? Can we design the control circuit so when you shut the line down, you have a power down button versus an e-stop button, and then it opens a valve and then you pump the system down over 30 minutes to your water recovery system versus flooding the floor system and everybody's walking around in 6 inches of water. But this chart will kind of indicate as you try and get down closer and closer and closer to 5 or 7 microns of filtration, you can see that, you know, in our environment with the debris loading and the water quality, it's going to get real expensive. So 200 gallon a minute RO systems, reverse osmosis systems, kind of start at the 750K range. And then depending what your water is, because we've learned that water is not the same wherever you go. Some water you literally can't really effectively filter down to those levels just because of all the minerals that are in that water. So here's a picture I talked about having remote chillers. This was a remote filtration system using a rotary filter, which would get down to 100 mesh filtering through a air injection tank. This is dissolved air filtration, which uses a micro bubble being injected. It's similar to your industrial sewer systems. They use the same technique. This is just used as a filter. It'll take out pigment on tomatoes, it'll take out oils, and it migrates to the top as a foam. You wipe the foam off and you vacuum it out of the system. There's also been a number of attempts at inline filters of varying success. And then there are available pre-canned, pre-engineered systems for filtering flume systems down with a canister method. Huge downsides in cleaning those canisters on a regular basis. And then there's also pre-engineered membrane, ultrafiltration membrane systems that are commercially available. So process piping, we talked a little bit about that on your survival guide. There's some great points on process piping to key on. But we are seeing a migration away from PVC threaded fittings to really the 3A dairy spec, sanitary triclam fittings, fully removable, and also designing it to be broken down. So you have areas you can separate for visual inspection. This is a picture of a waterfall, which is a common method to eliminate spray bars. So we all know spray bars atomize when they're mounted over shakers or over other conveyors. There will be an aerosol plume around that. So a water curtain, which is what this is called, will help minimize the aerosol effect. Process water cooling. Another topic we could go in depth about. We've seen a migration away from falling film chillers, which you see in the upper right corner, to an inline shell and tube chiller. So the goal is to short circuit, get your response time at your wash system where you don't have to have a chiller mounted remotely or way up in the air. These inline chillers we're putting right into the process water circuit and really having a very tightly wound closed loop system. So here's another shot in a plant of some chillers. They were elevated up right next to the process line. But you can see there is some infrastructure challenges and cleaning challenges that comes with a falling film chiller. So just going through the dryer operations, there's basket-based dryers, which take a lot of labor to do. They're very, very popular because of the flexibility they offer. And I think if you talk to most operations managers that are out there that are having to meet orders based on their product mix, this is really the only solution, having a batch dryer with baskets that they can turn on a dime and really hit the production numbers. But automated centrifuges are really now becoming very common. We've shipped a number of the large automatic dryers here in the last couple of years just because of the labor shortage. So we're seeing not only here in Salinas, but on the East Coast, everywhere, there continues to be a shortage of labor. But the point here of the chart, the capacity calculator, all the steps from filling the basket manually to transporting it and loading into the dryer, closing the lid, spinning it up, spinning it down, all those same steps happen in every automatic dryer. So once you understand that, you can then start to evaluate the pros and cons of different designs. How did one manufacturer solve this part of this common problem?
Question, could you take a big process plant like you showed Truly to take their spinning dryers and taking the buckets, filling it up, putting in the spinner, and taking it and dumping it in that space that they have that, is it possible to automate that? Because it seems like it's a lot going on in a very small space with all those people doing that manually.
Yeah, anything's possible with time and money. So.
Has it been done yet?
Yes, it has been done. So yeah, typically we've got, anybody's been to United Fresh Trade Show, we've got 3D printed models, and we show a typical inline dryer setup, and then the automated system, we've gone through and designed it to be basically the same linear space to drop it.
From the ground up for them, or did they convert over?
There's been cases where ideally from the ground up you would design it, but everybody is retooling. And it's a constant battle. Do we save space by scale feed elevators, steeper there? Can we shallow those out? Compressing wash systems with a newer style wash systems save space. So there's always, it continues to evolve to solve that space problem. Yep. So can't leave out air drying. This is common in Europe where volumes seem to be a lot lower, distribution ranges are a lot less, product is a lot weaker. This type of dryer though does break the temperature chain. So it's taking your product, you've cooled down, transported it at 34, 35 degrees. It's bringing it up to 68, 70 degrees, evaporating the water off. Now you've got warm product and all that vapor, all the moisture now is vapor, which you are freezing out of the air with coils. And then you've got to blow cold air back through the product. So some potentials there for thermal shock on the product, but it does eliminate some of the mechanical compression we see in spin drying. So there are certain products that, this is really the only valid solution for producing that product. Here's a couple more videos just showing you a batch operation in the upper right, an automated in the lower left, and then a batch animation of a batch operation automated with some robotics, manually moving small baskets versus a worker. So obviously all these techniques are being used in the industry today. Each company really boils down to the quality of the people you have. So we've seen the same lines go into customer X, Y, or Z. Each one giving the tools they run things differently. And they may hit numbers with some very primitive equipment that, wow, there's some good people here behind the equipment making it work. So we're getting towards the end here. I'm trying to wrap up here in the next couple minutes. You've learned a little bit already about vertical form seal systems. In the early days, a machine called a net weight filler was very common for the food service products. And then there's the manual pack out system, which uses tables. Those are still very common. So a lot of companies, smaller companies, are doing 200 to 300 different blends, mixes of product every day. So using preformed bags versus buying a big roll of film, which is maybe a $20,000 investment just for the film alone and the artwork and the tooling. So you can kind of balance out the flexibility. This shows you what happens infrastructure-wise to put in a combination scale vertical form seal. So first there's a mezzanine that goes up with the holes for the scales. You have some conveyance going up to it, typically also adding in a vibratory shaker to feed the system. And then the combination scale. And fresh cut is predominantly Ashita followed by Yamada scales. They're both very common. Sanitation in these areas has been brought up with being able to remove buckets to wash out. There's now parts washers that use heat that you can load these on a cart, transfer them into basically an industrial sized dishwasher to clean them with heat. Blending, we talked about blending. There's been a lot of post blending done at the scale feed area where we're using vibratory feeders, load cells to take 3-4 components and then blend them all prior to the scale. And there's also been blending done at the scale itself with segregating the buckets into it. There's a shot of manual packing operation, very common for some of the distribution centers that are maybe doing multiple products. For hand packing, loading on a conveyor, and then it goes through a band sealer for sealing. Another shot of that same type of process. So rigid tray conveyor packing is very common. Party trays, a lot of companies gear up for Super Bowls. I've been told that Mother's Day weekend is like the biggest day for produce sales, especially on the party trays. It seems to be the popular thing for us men to go through the produce department.
Effort for mom.
Yeah, and we'll buy the big party tray of broccoli, so eat healthy. So I don't know if this video will run. This shows you kind of a tray assembly procedure where you've learned a bit about what's the pace setting device on this. So the belt speed and the person loading the trays at the end of the line is the pace setting device. So these kind of lines are designed for you want bowls filled per minute, so you have one person placing a bowl on that line every 2 or 3 seconds to keep things moving along. There's also batch processing where people are paid by piecework. So this shows a table in the background where you can set your cantaloupe, honeydew, strawberries, all your different components, and each person gets to hand pack their own. They track how many that person packed and they're paid a piece rate on that. So very common, these are diced tomatoes, although they don't look like diced tomatoes in the video. Being filled. This is a very early manual system. There's now some great automated processes for filling these rigid containers. But sealing is always an issue. So there's water that contaminates the edge lip. Now you've got film that's going to be heat bonded to that, creates a whole nother aspect. So there's a machine called a flow wrapper, which is basically a vertical form sealed bagging machine that's turned horizontal. So your roll comes off, it forms a tube. Workers set the 4 or 5 pieces of celery sticks in that pocket, and then from there it goes through and gets packaged. So running right down the very end, there's also robotics being looked at. We really have been doing a lot of prototyping on this. I think it's still a little premature to happen, but the technology is there. So there's cameras now that can scan. You can see the picture in the upper right-hand sorter, sees all the product. It's tracking it on the conveyor belt, and then it can pick the pieces up individually, align them, set them in pockets at a set rate. It's also done a lot of work with mini sweets and other product that needs to be cut off at the tail. So now with camera technology, we can look at mini sweets, for instance, pick them up off a conveyor belt. The robot will line them up on the edge. From there, they're going to convey through a water jet cut to cut off the bottom end of it. And from there, they're going to go through a dicer and wash system, completely automated from start to finish. So as we now are fully in the bag, there's x-rays that occur at the packing step. There's leak detection that has to happen. There's case packing, and almost to the end here before our photo. Sorry, let's go back. So another whole discipline in the produce plan is your empty box delivery system. So countless hours have been spent trying to design in a hygienic delivery of boxes. So pallets of empty cardboard come in, they've got die cuts, there's debris. The debris field alone that comes off of one of these pallets is enormous. So segregating that into a mezzanine area, dropping boxes down through, and Salatime, all these videos came from companies that are no longer operating. So Salatime is gone, by the way, they've been reincarnated as something different. So right about the end, so this is a metal detector just to highlight changes that have happened over the years. So we're now not only sensing for metal detection, but we are also, once we get a positive for a bag, you now need to track that bag. So we're verifying that we wiped the bag off, it made it into what we're calling our bag coffin, and it's locked. So food safety is the only people that have access to it. The expectation is they collect those bags, they take it, open it up, and then determine what's in it. Was it a nut, bolt? Where did the nut and bolt come from? And we've got great photos I should probably share sometimes. They're just strange things that have made it into that coffin through the bag. I'm always amazed. It's like, how did that get from there all the way to that point? So now you're all experts. Good.